Today we are going to discuss another new topic which is a continuation with our matrices, that is chapter number 4, Determinants. So in our earlier we had a discussion about matrices and we have seen in matrices how to addition, subtraction, multiplication and finding the inverse, those kind of operations we have seen. Now the continuation part of the matrices is called determinants. Now today our topic is chapter number 4, Determinants. Now, what is the meaning of determinant? In our lower classes, means in your class 10, we have pair of linear equations. Pair of linear equations. So, solving a pair of linear equations, for example, when we have a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. When these are the two linear equations, when we solve these two linear equations, we have three kinds of solutions. One, we have the conditions for that. If a1 by a2 is not equal to b1 by b2, we have unique solution. Unique solution. Now similarly, when a1 by a2 is equal to b1 by b2 is equal to c1 by c2, when this condition gets satisfied, we have infinite number of solutions. Infinite number of solutions. Means, in first case, when a1 by a2 is not equal to b1 by b2, means the lines are intersecting lines. When the lines are intersecting, means the lines are lines. So, these we can say they are intersecting at one point, we have only one solution. When this condition gets satisfied, what is the condition? a1 by a2 is equal to b1 by b2 is equal to c1 by c2. In this case, we have infinite number of solutions. Whenever this condition gets satisfied, which means that the lines are coincident lines. Here, this is line 1 and on the line we have another line. Means these two lines are called coincide. So, coincident lines. When these two lines are coincident, you have infinite number of solutions. And the last condition is a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. When we get this condition, which gives us no solution. So we don't have solution for the given lines. So why it happened? Whenever this condition gets us, which gives the meaning, this is line 1 and this is line 2. So both lines are parallel. So parallel lines never intersect. If they never intersect, we can't get any solution. So to solve any two equations, we have three cases. Case 1, intersecting lines. Case 2, coincident lines. Case 3, parallel lines. When the lines are intersect, you have unique solution, means we have one and only solution. When the lines are coincident, we have infinite number of solutions. When the lines are parallel, we have no solution. Why we are recalling this concept? All these concepts are from your class 10. Now why we are recalling? What is the relation between these pair of linear equations and with our present concept determinants? Let me explain. Now, these linear equations can be converted in the form of matrices. How to convert, sir? Here, the coefficients a1 B1, A2, B2. So here x and y are the variables. The coefficients we are considering as a matrix, and the variables are x is a variable and y is a variable. It we are writing as a matrix, and the constants C1, C2 is also a matrix. So the pair of linear equations we are able to convert in the form of matrices form. As we know the product, it is a square matrix 2 by 2, and it is a column matrix 2 by 1, and it is also a column matrix 2 by 1. When we multiply a1 into x plus b1 into y is equal to c1, a2 into x plus b2 into y is equal to c1. Again you get the linear equations. Now the linear equation we have converted in the form of matrices form. As I gave the condition, unique solution. Unique solution means what we have? A1 by A2 is not equal to B1 by B2. When we go for cross multiplication, A1 into B2 is not equal to A2 into B1, which gives us A1 B2 minus A2 B1 is not equal to 0. A1 B2 minus A2 B1 is not equal to 0 means here A1 B1 A2 B2 these are our constants. When we go for cross multiplication, A1 into B2 and A2 into B1, these two values are not equal. By applying the transposition, you have the condition of that A1 B2 minus A2 B1 is not equal to 0 means it is a constant. This constant is not equal to 0. When it is not equal to 0, so A1 B2 minus A2 B1 must be equal to some k, which is a constant, means which we have a value. This value is nothing but called determinant. Determinant is nothing but for every matrix we have one value. That value is known as determinant. That is the introduction concept. When we have a pair of lines, pair of linear equations, we have three conditions. The lines may be intersect, or the lines may be coincident, or the lines may be parallel. When the lines are intersect, we have a condition of that A1 by A2 is not equal to B1 by B2. When we come for cross multiplication, we have a condition of that A1 B2 minus A2 B1 is not equal to 0. When this constant is not equal to 0, means it may be equal to some other constant. Let us have the constant k. This constant k is nothing but the value of the matrix. This constant k represents the value of this particular matrix. That value is known as determinant. So finally, the definition of determinant is for every matrix we have one value. Every matrix represents one constant. That constant is known as determinant of a matrix. Now, our concept is determinants means whatever the matrices are given, for that matrices we are going to find the value.
3.
Here we have determinant for a square matrix. We have matrix A with 2 rows and 2 columns. The order of this matrix is 2 rows and 2 columns, which is called a square matrix. When there is a matrix A, then what about determinant of A? So this determinant of A we can write it as this. Usually this symbol we call in number system modulus. Here we are calling it as determinant. So we have to read it as, here I have given determinant of A. We have to read it as determinant of A, not modulus of A. So determinant of A is equal to determinant, the matrix we are taking the element A, B, C, D. How to get the determinant? We have to go for cross multiplication. So first the diagonal elements we have to multiply. A into D, AD minus these two cross product B into C, BC. So A into D minus B into C, AD minus BC, which gives one constant value. This constant is known as det of A. There is a square matrix, and for square matrix we are finding determinant. As I told you, determinant means for every matrix we have one value. Every matrix itself it has one value. That value we are finding, that value itself is called determinant. How to find the determinant means first multiplying the diagonal elements A into D minus again these two cross elements B into C. AD minus BC gives us a constant. This constant is known as determinant of A. So that A we can represent either in this form or in this form. Anyway we can represent. And one more important condition of that, only square matrices have determinants. When there is a rectangular matrix, we don't have determinant, we can't find. For example, when we have the matrix A, 1, 2, 3, 4, 5, 6, when it is a rectangular matrix, how to find the product of diagonal elements? Here we don't have diagonal. When we consider diagonal, these two elements will come. Then what about this element? When we consider diagonal, these two elements will come. What about this element? So we are missing the elements. So the determinant is not at all applicable for a rectangular matrices. It is applicable only for a square matrices. Today in our class we are going to discuss how to find determinant for a 1 by 1 square matrix and 2 by 2 square matrix. Today just we concentrate with 1 by 1 and 2 by 2 square matrices. Later we discuss about how to find the determinants for 3 by 3 square matrix. Let us see here, finding the determinant of a matrix of order 1. So of order 1 in the sense which is having only one row and one column, means we have only one element. For example, let A is equal to A. So here it is representing a matrix which is having one row and one column. So the order of this matrix is 1 by 1. We can call simply order 1. So a square matrix of order 1 means it is be the matrix of order 1, then determinant of A is defined to be equal to A. Means for this order 1 matrices, nothing is there to calculate. Whatever the element we have, that element itself, it represents determinant of the given matrix. Means here the matrix consisting the element A, that element A itself representing the determinant. So 1 by 1 matrix means we have one row and one column, which means we have only one element. That one element itself it represents the determinant of the matrix. So nothing is there to calculate for the order 1 matrices. Now coming to the another one, determinant of a matrix of order 2. As I told you, determinant is applicable or determinant we can get only for a square matrix. So determinant is not at all possible for a rectangular matrix, that we know very well. Now here we have order 1 matrix, now we are discussing order 2 matrix. Order 2 means which is a square matrix with 2 rows and 2 columns. Now I have given one example for you. There is a matrix A which is having 2 rows and 2 columns, 5, -1, 4, 2. Now for this 2 by 2 square matrix, I need to find the determinant. So det A is equal to det, the element which are there in the matrices we have to write 5, -1, 4, 2. As I told you how to calculate the determinant means, first we have to go for principal diagonal elements product, means 5 into 2 minus, so again these two cross multiplication, 4 into minus 1. So first, this principal diagonal element should multiply 5 into 2 minus 4 into minus 1. So 5 into 2 minus 4 into minus 1. When we simplify, 5 2s are 10, minus of minus plus 4 1s are 4. We have 10 plus 4 is nothing but 14. This 14 represents the value of the matrix A, and which gives us determinant of the matrix A. So the determinant is applicable only for a square matrix. When we have order 1 matrix, the element itself it represents the determinant of the matrix. When we have a 2 by 2 square matrix, this is the process to find the determinant of a matrix. Here we have two different examples. Example number 2. Evaluate. This is not matrix. Just remember that whenever you have this modulus symbol, which indicates the determinant of the matrix. So matrices usually we put using the square brackets, which represent matrix. Here we are using two vertical lines. These two vertical lines are nothing but called modulus, and which represent determinant of the matrix. So evaluate means they are asking what is this determinant value. So just we are finding, as we know that first we go for the cross multiplication of the principal diagonal element. So x into x minus the another diagonal elements product, x minus 1 into x plus 1. So we have x plus 1 into x minus 1. X into x gives us x square minus x plus 1 into x minus 1, like a plus b into a minus b. So a plus b into a minus b is nothing but a square minus b square. By using that identity, we can able to write x square minus 1. So by simplifying this, we have x square minus into plus minus x square minus into minus plus 1. So finally here plus x square minus x square can get cancelled. We have the value 1. Means this entire determinant gives us the value 1. This is about example number 2. And here we have another interesting example, that is example number 5. What is this example number 5? Find the value of x. They are asking the value of x for which det 3x x1 is equal to det 3 2 4 1. Don't think that these two are matrices directly we can compare the corresponding elements. When we think about comparing the corresponding element, when we compare these two elements, here you are getting the value of x is equal to 2. When we compare here, the value of x is equal to 4. So x you are getting two different elements. So it is not the meaning of comparing the matrices. It is not the meaning of comparing the matrices. The meaning is the determinant of this left hand side matrix, determinant of the right hand side matrix, both are equal. So we should not compare the corresponding element. We have to compare the determinants of the matrices. So first what we are doing, finding the determinant for left hand side, finding the determinant of right hand side, and both we are equating. So that is the process we have to do it. Now let us see. The left hand side we have the matrix 3x x1. We are finding the determinant. So the cross multiplication, 3 into 1, 3 ones are 3 minus x into x square is equal to right hand side determinant, 3 ones are 3 minus 4 twos are 8. Now when we compare both sides, we have plus 3 and plus 3 can get cancelled. We have minus x square is equal to minus 8. Again both sides minus can get cancelled. We have x square is equal to 8. As we know that square comes this side becomes square root. So x is equal to square root of 8. Square root of 8 is nothing but plus or minus 2 into root 2. So the value of x is nothing but either plus 2 root 2 or minus 2 root 2. By taking the value of x either plus 2 root 2 or minus 2 root 2, the determinant of the left hand side and the determinant of the right hand side both will get equal. This is about example number 5. Now, in exercise 4.1, we have another different model, that is problem number 3. What is given in problem number 3? We have a matrix A, 1, 2, 4, 2, which is a square matrix with 2 rows and 2 columns. Show that det 2A, don't read it as modulus of 2A, which indicates that determinant of 2 into A is equal to 4 into det A. So whenever we ask show that, usually taking LHS, by simplifying the LHS we show RHS, or sometimes we take RHS, by simplifying the RHS we show LHS. So to take LHS or RHS, so let us find individual values. Given that, what is given? There is a matrix A, 1, 2, 4, 2, which is a square matrix. Let us find the determinant of the given matrix. So det A is equal to det 1, 2, 4, 2. So how to find its determinant? As we know that the product of principal diagonal elements 1 2s are 2 minus another cross elements 4 2s are 8. So 2 minus 8 gives us minus 6, which is nothing but det A. Next, here LHS what is required? 2 into A. So first we need to find 2 into A, means 2 into the matrix scalar multiplication. So 2 into the matrix A, 1, 2, 4, 2, multiplying each element with 2. 2 1s are 2, 2 2s are 4, 2 4s are 8, again 2 2s are 4. Now coming to the LHS. What is our LHS? Det 2A. So det, the 2A is 2, 4, 8, 4. Then we are finding the determinants, the cross product. 2 4s are 8 minus 8 4s are 32. 8 minus 32 gives us minus 24. Minus 24 I can write it as 4 into minus 6. That can be written as 4 into minus 6. Minus gives 6 gives us det A. So in place of minus 6 I can write det A value. So finally I got 4 into det A. So here I am taking the LHS part, det 2A, and finally I got the answer 4 into det A. That is the thing they asked to show that. Now from this example we can give one conclusion. What is that conclusion? Whenever you have a square matrix, here A is a square matrix with n by n, means here the order of the square matrix is what? N, means n rows and n columns. Whenever you have a square matrix with order n, det k into A, det k into A becomes k power n into det A. K power n into det A. So always the determinant of k into A gives us k power n into det A. Here n is nothing but order of the matrix. For example, if it is 2 by 2, here n gets us 2. If it is 3 by 3, n gets us 3. So this is the concept we are getting from this example. Let us see one more example. If there is a matrix A, which is a 3 by 3 matrix, 3 rows and 3 columns, means the order of this matrix is 3. Now I want to know that 3 into A is nothing but, as per the concept, that k into A gives us k power n into det A. Here we get 3 power 3 into det A, which gives us 27 into A. So this point is important for us to understand the concept. Here we have another problem, that is problem number 7. In this we have two problems. Let me explain the first problem. The question is that find values of x if means here the determinant of the matrix 2, 4, 5, 1 is equal to the determinant of the matrix 2x, 4, 6, x. So the left hand side we have a square and right hand side also we have a square matrix. The determinant of the left hand matrix, the determinant of the right hand matrix, both are must be equal. When the determinants are equal, what is the values of x? So that is the question. Now let us see how to solve this problem. First, the given question is 2, 4, 5, 1. Det 2, 4, 5, 1 is equal to det 2x, 4, 6, x. Now we go for the defining the determinant. As we know that 2 1s are 2 minus 5 4s are 20 is equal to 2x into x, 2x square minus 6 4s are 24. By applying the transposition, 2 minus 20 gives us minus 18 is equal to 2x square minus 24. Minus 24 comes this side becomes plus 24. So we have 2x square is equal to 24 minus 18 and it gives us 6. 2 is multiplying both sides and divide. X square gets us 3. So x is equal to plus or minus square root of 3. Finally, x has two values. One is positive, another one is negative. So x it may be plus root 3 or minus root 3.